Hello, this is Mr. White, and in this video I'm going to very quickly go through the solutions to the Chapter 4.3 practice problems. If you feel completely lost or overwhelmed about a particular topic here, this video will probably not be adequate for you. But this video is intended for the student who feels like they have all the puzzle pieces and they're just not quite able to put them in place. So hopefully this video will give you the little nudge that you need to feel successful on these problems. Let's get to it. Question number 1, what is the measure of 330 degrees in radians? This is simply a conversion problem, converting just like we should be able to convert inches into feet. Here we need to be able to convert 330 degrees into radians. We should know that our conversion factor, we should know that pi radians equals 180 degrees. And therefore this entire fraction here, this entire conversion factor technically equals 1. It's always allowable to multiply by 1. And here we are doing so just to convert the units. So we get 330 pi over 180 radians. The degrees cancel out. You don't have to write radians afterwards, although if you like, you may. We now just reduce the fraction. Both the numerator and denominator are divisible by 30. So if I divide the top by 30, I get 11 pi. If I divide the bottom by 30, I get 6. 11 pi over 6 is our answer, C. Question number 2, an angle measure of negative 4 pi over 3 is coterminal with which of the following angles? Yes, all the angle choices are in degrees, whereas our original angle is in radians. We may convert if you like, just like we did in the last problem. I'm actually not going to. I don't feel it's absolutely necessary. What is more necessary here is being aware of where this angle lies on the xy plane. So per our usual practice, here is our pi radians, our half a pizza. According to that denominator, we should cut it into 3 slices. So there's my reasonable picture of pi cut into 3 slices. I'll do the same for the bottom pi radians. All right, now our negative 4 pi over 3, that tells us that we need to rotate in the negative direction here, and let's count them off. Negative 1 pi over 3, negative 2 pi over 3, negative 3 pi over 3, negative 4 pi over 3. I see that this is the angle that we are interested in. Now, which of these following degree measurements is coterminal with that? I can tell that all of these degree measurements are positive. So rotating in the positive direction, I've got 60 degrees here. I go another 60 degrees to get 120 degrees. That is coterminal with the original angle in radians. Question number 3, an arc that is 11 inches long and has a central angle measure of 7 pi over 3 has a radius of what? Well, we are given information about an arc, and we are also given information about an angle. It should immediately come to mind to the well-practiced student that we are going to be using our S equals R theta formula. So let's plug in the 11 inches for S. Let's plug in the 7 pi over 3 for our angle. And we are left trying to find out what R is. Now, many times students will take the 7 pi over 3 and they'll divide both sides by 7 pi over 3. You may do that. I'm just going to do what I prefer. I prefer to go ahead and just multiply both sides by the reciprocal of that fraction, multiplied by 3 over 7 pi on both sides. So on the right side here, I see that I will now be left with R. Let me move everything over here just a little bit. And go ahead and work with the left side here. I've got 3 times 11, that gives me 33 inches over 7 pi. It's very tempting for a lot of times for students to take that pi and put it up in the numerator because that's where we normally see it. But we see very clearly here that pi is in the denominator. So this is our answer, and we see that is answer choice, let's see, B here. So this just came down to S equals R theta in radian measure. All right, 4, what is the quotient secant of theta over tangent of theta? Quotient, that just tells us we're dealing with division, which is kind of evident right there. So what is secant of theta divided by tangent of theta? This comes down to, do you know your definitions of trig functions? Secant of theta, that is the reciprocal of cosine, right? Which is adjacent over hypotenuse. Therefore, secant must be hypotenuse over adjacent. We will take the quotient of secant and tangent theta in the denominator. Tangent is opposite over adjacent. This is where students will typically say dividing by this fraction is the same as multiplying by its reciprocal. So let's go ahead and do that. Let's keep the numerator the same, the hypotenuse over adjacent. Let's multiply by the reciprocal of this denominator, which is adjacent over opposite. We see that the adjacents divide each other out. We're left with hypotenuse over opposite, which is cosecant of theta, A. All right, question 5. 5 different students calculate the following to be the sine of an angle, but most didn't bother to simplify their answers. Which is different from the other? So the claim is that 4 of these 5 are equal to each other. This really is not as much about trigonometry as much as it is about just working with radicals. So how do we resolve which are equal to each other? There are a number of ways, and one could go about this in a number of different orders you could attack it. I think the first thing that jumps out to me is that I see that 2 of these answers have 7 as a denominator, so I'm kind of drawn to those 2. I look at the numerator for answer A, and I see this square root of 18, and I think, I can simplify that. Square root of 18. We should know, working with radicals, that we are allowed to split that up into square root of 9, square root of 2 over 7. We know square root of 9 is just 3, radical 2 over 7. And we see that that does match answer choice D. So we know that A and D are actually equal to each other. Let's see, I saw that 18 here. I saw 18 in the numerator for A. So I noticed that 18 also occurs in the numerator for C. You should know that with radicals, you are allowed to divide this up into square root of 18 over square root of 49. We know that that bottom, 49, is a perfect square, so we know that this simplifies to root 18 over 7. And we say, hey, that looks just like our original answer, choice A. So we know that this also matches the answer choices A and D. I look at what's left. Let's see, we've got all these denominators of 7. So I look at this root 7 down here for E, and I think, let me turn that denominator into a 7. I'll do that by multiplying the bottom by root 7, and if I multiply the bottom by root 7, I got to do the same with the top. So that gives me 3 root 7 over, now I just have 7, and I see that is not the same as the other answer choices. So that looks to me to be the one that is different from the others. Just to be extra sure, we'll go ahead and check out answer choice B. If I rationalize that denominator, I'm going to multiply the bottom by root 2, and I will do the same with the top. That will give me 6 root 2. And on the bottom, I've got 7 times 2, which gives me 14. And I see here that 6 and 14 are both even numbers, so I will reduce those down to 3 over 7. And I'll have that root 2 still there. And I see that does match answer choices A and D there. So I know that, yes, indeed, answer choice E was the one that is different from the others. All right, in exercise number 6 here, we are to find the length of side B. This is a fairly basic, just right triangle trig problem. So remember the question we ask is, when we're looking at theta here, we ask, what is the side that I know? Well, we know what this side is, and that is the opposite side. And what is the side that we want to know? That would be the adjacent side. So again, what is the side that we know, and what is the side that we want to know? Once we've identified those, we see opposite and adjacent. And which trig function does that make you think of? Well, in reality, 2 of the 6 trig functions would handle opposite and adjacent. There's cotangent, that would work, but most students are going to think of tangent instead. So let's go with that one. So you write the equation, tangent of theta equals opposite 3 over adjacent B. Now, we have to get B by itself, and there are several ways one may go about this. Students tend to develop their different preferences. The way that I'm going to go about it is to multiply both sides by B. Be careful. I see a lot of students at this point try to cancel out the 3. They multiply both sides by 1/3. You may do that. You can do that, but make sure you don't make the mistake of saying that you end up with B on the right side. You don't end up with B. You end up with 1 over b, and I find that a lot of students miss that point. So anyway, I'm going to back up and go about it a different way. I'm going to multiply both sides by b itself, because it is the denominator over here on the right side. And as long as I do the same thing on the left side, I'm good here. So the b's cancel each other out. We have b tangent theta equals 3. And from there, I remember that I'm trying to isolate the b, so I will divide out the tangent theta on the left, and therefore do the same thing on the right. Divide by tangent theta. Now, a lot of times students at this point look at the answer choices and go, wait a minute, I don't have 3 over tangent theta as an answer choice. Well, yes you do. Think of that 3 divided by tangent theta. Think of it as 3 times 1 over tangent theta. I hope you agree that mathematically those are the same thing. And when you realize that 1 over tangent theta is just cotangent of theta, that means that our answer choice is D. All right, let's go on to number 7. Identify the one angle that is not coterminal with the others. The implication is that all of these angles are not equal but coterminal except one of them. So we have to identify where they all lie on the xy plane. Let's start with negative pi over 3. We'll divide our bottom half of the xy plane, our bottom pi, into 3 equal pieces with that slice and that slice. Let's go ahead and do the top half while we're at it. I'm going to just get rid of the y-axis. That's just sort of a distraction right now. And option A, negative pi over 3, lands right here. Negative pi over 3, that's where answer choice A is. Let's look at answer choice B, 420 degrees. So I need to envision an angle that sweeps a full 360 degrees, and I ask myself, how much further do I have to go to get to 420? Well, 360 plus 60 equals 420, so that means I need to go an additional 60 degrees. We already see a difference. A and B are not at the same location, so we know our answer is one of those. Let's go ahead and let's see, be a tiebreaker, negative 5 pi over 3. So I start at 0 and I sweep negative 1 pi over 3, negative 2 pi over 3, negative 3 pi over 3, negative 4 pi over 3, negative 5 pi over 3. It looks like A is the odd one out. We can quickly confirm that D and E also agree with B and C here. Let's just do that real quickly. Answer choice D, 13 pi over 3, positive 1 pi over 3, positive 2 pi over 3, positive 3 pi over 3, 4, 5, positive 6 pi over 3, 7, 8, 9, 10, 11, 12, positive 13 pi over 3. Answer choice D looks good here. And finally, negative 300 degrees. If I sweep backwards, a negative 360 degrees, but I went a little too far. If I'm trying to get to negative 300 degrees, I need to back up or go forward actually 60 degrees. And I just conclude that this is where negative 300 degrees is. So answer choice E is here, and forgot to move this little circle along, but we see that A is the odd one out here. That is the one that is not coterminal with the others. All right, 8. Choose the point, and I emphasize a point, on the terminal side of theta equals 135 degrees. We've got problems like this in the homework, and I emphasize point because sometimes we see this notation with parentheses, and sometimes that represents an interval, not a point. But I'm telling you this is a point, xy coordinates, and I'm telling you that the angle we're dealing with is 135 degrees. So let's figure out where that is on the xy plane. Here's 0 degrees, positive 90 degrees. If I go another 45 degrees, there's my positive 135 degrees. And we finish drawing our triangle here so that we get the x and the y coordinates. We are dealing with the 45, 45, 90 degree triangle in the second quadrant. And think of what numbers we normally associate with this triangle. We normally put a 1, and a root 2. Now we have to consider which one of those is negative. Well, this side is negative. And we consider that the point that we normally associate with this angle is x value negative 1, y value positive 1. But we need to recognize there are infinitely many more points on that line. I could give the coordinates of that point, or that point, or that point, or that point. They all lie on the 135-degree ray there. So what are some other possibilities? Well, if I went with this point right here, I could say that's -1/2, +1/2. Or if I went further out, I could say this is, let's see, -π, +π. I could go to -1,000, +1,000. Anything I want that fits that pattern. I look at my answer choices and basically see, again, I'm looking for negative x value and then positive y value, that both have the same magnitude. So even though these are not numbers that we normally associate with this triangle, option C fits the pattern. -√3 would be approximately -1.7 something. Positive √3 would be approximately +1.7 something. So that would land me somewhere right around here. This drawing is not perfectly to scale, but I hope you got the idea here, that we can confidently say answer choice C lies on that terminal side. All right, question number 9. Find cotangent of theta if sine of theta equals 7/8 and secant of theta is greater than 0. The fact that we're alluding to the idea that this has to be positive and that it even has the possibility of being negative, that hints at the idea that we're working on an xy plane. Whenever we are hinted that we may be dealing with negative numbers, that hints that we're on the xy plane. So let's go ahead and draw that. And if let me go ahead and draw the bow tie that I encourage you guys to draw. I don't know if this is to scale. I may not be drawing the angle quite right, but I at least want to figure out what quadrant I'm in. So let's do that. Let's see, we alluded to, well, let's go ahead and look at the sine of theta equals 7/8. I'm not worried so much about the number 7/8. I'm just going to focus on the fact that 7/8 here is a positive number. And ask myself, where is opposite over hypotenuse going to be positive? Well, it looks like in those first two quadrants we'll have a positive sign, whereas in quadrants 3 and quadrants 4 I would have a negative opposite over hypotenuse. So we know we're not dealing with quadrants 3 or 4. Now, the tiebreaker is that secant hypotenuse over adjacent has to be greater than 0. Secant has to be positive. So over in second quadrant, my adjacent is negative. So hypotenuse over adjacent would be negative, not positive. So I can't be working in that quadrant. I must be working in the first quadrant here. If both secant and sine and secant are both positive, right? All right, so let's put some actual numbers there. Let's go ahead and go back to the sine of theta equals 7/8. Let's put +7 and +8 as our opposite and hypotenuse. And if we want to find out that third side, which I do, let me point out that we do need to find the third side because that will be involved in calculating cotangent. We use the Pythagorean theorem. Let's go ahead and call this x. And Pythagorean theorem says x squared plus 7 squared equals 8 squared. I do find a lot of students kind of mess up the Pythagorean theorem in various ways. If you know you're not 100% confident in that, please follow up. X squared plus 49 equals 64. Subtract 49 from both sides, get 15. X equals positive square root of 15. We had earlier determined that x must be positive. So square root of 15. And if I'm doing cotangent of theta, where this is theta right here, I'm doing adjacent over opposite. So adjacent, square root of 15, over opposite, 7. That would be my cotangent. That means option A is our answer. Question 10, which of the following is undefined? We are working on an XY plane here. I see a bunch of quadrantal angles, angles that lie right on the edge of two quadrants. So let's go ahead and draw an XY plane. Let's just kind of go down the list here and look at a few of these. Secant of negative 180 degrees. I identify where that is. Negative 180 degrees, I'm going in the negative direction. Negative 180 degrees, as I'm surely explained in class, I'll draw it off just a little bit, just so I can really envision a triangle here. And I'll draw my vertical line to the axis. There's my adjacent side. And I put the numbers that we normally associate here, a positive 1 for the hypotenuse, a negative 1 for the adjacent, and a 0 for the opposite. Remember that triangle isn't really there. That opposite side is really just 0 in length. And I asked myself, what is secant? Secant is hypotenuse over adjacent. So 1 over negative 1. That just equals negative 1, and that is not undefined. That is not our answer choice. So I'm not going to go through every single one of these here. If you have trouble with quadrantal angles, as many students do at the beginning of their trig adventures, you need to, please follow up on that. But let's go ahead and look at the, let's say, option D here, cotangent of 0. So I draw the appropriate triangle for that one. 0 radians, 0 degrees, just lies right there. I draw it off just a little bit. Complete the picture, 1, 1, and then 0 is the opposite. And cotangent of 0 would be adjacent over opposite. So that one would equal 1 over 0. That is undefined. If we looked at all the other ones in that same manner, we would find that this is the only one that is undefined. Therefore, our answer choice is D. All right, question 11. If theta is the smallest angle in an 8, 15, 17 right triangle, then secant of theta equals what? I don't really see any indication here that we're working on an xy plane. If you want to draw the x and y axes and work off of the xy plane, you may, but I don't see a necessity in doing that. So let's just draw some right triangle. I'll go ahead and tell you these do form a Pythagorean triple. You can verify that 8 squared plus 15 squared does equal 17 squared. Or you can just take me at my word. I'm not trying to fool you in that manner on this test. So let's just draw a reasonable picture here. I'm going to say here's a reasonable picture in which I'm going to claim that this represents the 8, this represents the 15, and the longest side is the 17. That's the hypotenuse. And let's see, if theta is the smallest angle, we have to figure out where theta is. Theta is the smallest angle, and the picture sure suggests which one theta is. And we should remember from geometry that the smallest side is always across from the smallest angle in a triangle. So that's what tells me that theta is located right here. All right, and we want to find secant of theta. So secant is hypotenuse over adjacent. So hypotenuse is 17 over adjacent 15. We see that the answer we want is D. Number 12, evaluate cotangent of 11 pi over 6. That's a rather large angle. We are definitely working on the xy plane. If you were to convert that into degrees, you would find that's much more than 180 degrees. So again, that's a clue that we're working on the xy plane. And the fact that we're not allowed a calculator tells us that we are definitely working with a special triangle. And I hope you can tell based on some of the clues in the angle there, 11 pi over 6. 11 pi over 6, that's what tells us that we'll take the top pi radians and divide it into 6 equal pieces, 6 equal slices. And I will do the same with the bottom pi radians, 6 equal slices. And we will count off 11 pi over 6, 1 pi over 6, 2 pi over 6, 3, 4, 5, 6 pi over 6. 6 pi over 6 reduces to pi, which is what I would expect to see here, so we're on the right track. 7 pi over 6, 8, 9, 10, 11 pi over 6. From my reasonable picture, I can tell that I'm dealing with a 30, 60, 90 degree triangle. We typically associate 1, radical 3, and 2 with those sides. Make sure that you get them in the right place. Make sure that you recognize, I find a lot of students erroneously put the root 3 as the hypotenuse, but 2 is the biggest number here, so that's the hypotenuse. And we also should recall which one of these is negative. So one of these is, has a negative value, the opposite does here. All right, so we got the groundwork laid here, and if we want to evaluate cotangent, that would be adjacent over opposite. So root 3 over negative 1, adjacent over opposite, and that is equal to D. Number 13, for all values of theta on the interval, 3 pi over 2 to 2 pi. Let's emphasize the word interval. That's what tells us that we are not dealing with x, y coordinates. That is not the case here. This is an interval. We've presumably discussed this notion in class, and you've presumably seen something like that on the homework. We are dealing with this interval of theta, and 3 pi over 2, if I'm thinking of that as an angle, this is where 3 pi over 2 is on our xy plane. 2 pi, that is a full circle. So this interval is simply telling us that we are working somewhere here in the fourth quadrant. We don't have any clues to whether we're dealing with a steep angle or a shallow angle or somewhere in the middle. Doesn't really matter for this question. Just draw any triangle in there and just focus on the sign, positive or negative sign. The opposite, regardless of what angle we're dealing with in that quadrant, the opposite will definitely be negative. The adjacent will definitely be positive in the fourth quadrant, and the hypotenuse is always positive. So now that we've got the signs, S-I-G-N sign of these triangle sides, we can go down the list here. Let's see, sine of theta is greater than 0. We see that sine would be a negative over a positive, and that would not be greater than 0. So not true. Let's see, cosine greater than 0. Cosine theta greater than 0. We see that adjacent over hypotenuse does look like it's positive. So that appears to be our answer, right? We can quickly look over the other three. Tangent greater than 0. That would be negative, whoops, error there. Negative over positive, opposite over adjacent. We see that option C is incorrect. Secant is less than 1. We see that secant would be hypotenuse over adjacent. The hypotenuse is always larger than the adjacent, so secant will always be a bigger number over a smaller number, except in the case that they're equal. But we will never have secant being less than 1. That's impossible. So that's not true. And cotangent greater than 0, is that true? Cotangent adjacent over opposite, that would be negative. So no, this is not true. We can say for sure that B is our answer there. All right, 14, what is the total perimeter of a sector? I'm giving you a hint that we're talking about a pizza slice, although you really should know that term by now, sector. Sector as opposed to an arc. There's an arc right there, but a sector refers to the whole slice, the whole pizza slice. Now, rather than focusing too much, that looks a little too much like a right angle, and I'm not trying to imply that, so let me draw something a little different. There, big pizza slice. Has a central angle of 1.5 radian. If you remember that a radian is about 57 degrees, you'll notice that I tried to draw this picture as a reasonable 1.5 radian. But even if you don't get this picture to scale, it's not the biggest deal in the world. We just need to get the concept down. That's where theta is, and it equals 1.5 radian. And the radius is 20 centimeters. So that means this side is 20 centimeters. And of course, this radius is also 20 centimeters. And we are asked for what is the total perimeter of the sector. Well, total perimeter. That tells us we're not just interested in just the arc length. This just comes down to careful reading. We don't want just the arc length. We want the arc length plus these two radii. That's the total perimeter, right? So let's start with the arc length. We'll go ahead and say that the arc length S equals r theta, which equals 20 centimeters times theta is 1.5. We see that the arc length is 30 centimeters. And if we go ahead and add 30 centimeters plus 20 centimeters plus another 20 centimeters, that would give us 30 centimeters for the arc, 20 and 20 for the two radii. That would add up to 70 centimeters for the perimeter. So our answer is E. 15, pick the statement below that is false. The implication is that most of these are true and that one of them is false. I'm not going to go down every single one in the list. I would ask that you review them and hopefully convince yourself that most of them are true. But let me go ahead and single in on two of them here. I want to contrast two of them specifically. So let me get E off the screen. Let's get D out of here, and let's get B out of here. Those are all true, by the way, B, D, and E. Let's go ahead and contrast C and A. Let's look at C first. For an acute angle theta, if sine of theta is less than cosine of theta, then 1 is less than cotangent of theta. Key word here is acute. If we are thinking on an xy plane, the word acute tells us that we're really just dealing with something less than 90 degrees. We're really just sticking to this first quadrant here. That is what we gather from the word acute. So ignore the other 3 quadrants. Anyway, sine of theta is going to equal, oops, not adjacent. Sine will be opposite over hypotenuse. And we are being told that is less than cosine, which is adjacent over hypotenuse. I can multiply both sides by hypotenuse and get the fact. We are implying that or inferring that opposite is less than adjacent. Okay, well, let's look at the conclusion we're trying to draw. We're trying to draw some conclusion about 1 and cotangent. And if you really know these trig functions well, you'll then say, well, how do I get a 1? I can divide opposite by opposite. How do I get a cotangent? I can divide adjacent by opposite. And we draw the conclusion that 1 here is less than cotangent theta. So starting with this fact, we have deduced that this must also be true. And the fact that we were working the first quadrant assured us that all these values, the opposite and adjacent, that assured us that we were working with positive values the whole way. So we can be sure that this is true. So it appears that C is a true statement and therefore not the one that we want to circle. I want you to contrast that with answer choice A. Notice that in A, I don't say anything about being an acute angle. That's really sort of the little catch here. And if we were to erroneously assume that we are working with acute angles, we might think of something like this. We might think of, let's see, an angle here and an angle here, both in the first quadrant. And I might say if alpha is less than beta, well, then I would draw alpha here as the lesser of the 2 angles and beta here. And we may look at those and just try to quantify. I'm just going to kind of look at this geometrically and see sine of alpha would be this side over this side. And sine of beta would be this longer opposite over the same hypotenuse. So noticing that the opposite side of beta is larger than the opposite side of alpha, I may be inclined to believe that this is a true statement. That would seem like a reasonable conclusion to draw. But let's consider that we were never constrained to be dealing with acute angles here. So let's look elsewhere on the xy plane. So let me just show one counterexample that shows that this is not a true statement. Let's say we're dealing with this angle alpha. That is alpha right there. And let's say beta is this angle over here, basically the quadrantal angle along the negative x-axis. Well, in this case, sine of alpha is opposite over hypotenuse. We do have some positive number here, but notice that sine of beta over here is our opposite 0 over our hypotenuse. That basically equals 0. If I wanted to draw beta down here in the third quadrant, I could even get negative values for sine of beta. If I drew beta somewhere here in the third or fourth quadrant. And notice in those cases, beta is definitely bigger than alpha, but sine of beta gets into negative territory. In any case, I hope that's clear. This is one where I definitely would want you to follow up. I always have questions about this one every year. This one is definitely false, and therefore it is the one that we want to circle. All right, this question, which of the following sequences of numbers is listed in ascending order? And you're not allowed to do this with the calculator, so how are you to do this? Let me tell you where this question comes from. It comes from the fact that I see a lot of times students mislabeling their triangles. For example, with the special triangles, I see this all the time. And we should know that that doesn't make sense. Even if you don't know exactly what square root of 3 is as a decimal, you can square all these sides. If I square this, and I square this, and I square this, I get 1, 4, and 3. And I see that, oh, the square of this is the biggest, therefore 2 itself must be bigger than square root of 3 and 1, of course. So again, comparing the squares of these numbers allows us to order the numbers themselves. Hope that made sense. So let's look at the three numbers we're dealing with. It looks like the same three numbers in all three cases, or in all five answer choices. So let's just look at them. 7, 3 root 5, and 4 square root of 3. Since I don't know what those are as decimals, again, I'm going to compare their squares. Well, 7 squared, straightforward enough, right? 49. 3 root 5 squared, that's going to give me 3 squared gives me 9. Root 5 squared gives me 5. 45. I see that is less than the 49 over here, so that allows me to draw some conclusion. 4 root 3 squared, that's going to give me 4 squared, which is 16, times 3 squared, which is 3. That's going to give me 48. So I look at the three square values, 49, 45, and 48. And the least one is 45. So that means that our original 3 root 5 is the smallest. The 49 here is the largest, so I know that's the largest. And of course, the 4 root 3 must be in the middle. So we see what answer choice satisfies that. Let's see, 3 root 5 is the smallest, 4 root 3 is the middle, and then 7 is the largest. That would be answer choice E. 17, draw a reasonable sketch of a right triangle with theta equals 89 degrees. And then draw a conclusion about which of these trig functions would have the greatest value. Here's where this question is coming from. I see a lot of students just drawing some generic triangle and then trying to fill in whatever angle they want into that triangle, trying to tell me that that's 89 degrees, or even worse, sometimes I'll see students try to put in obtuse angles here, saying that's 167 degrees. No, it's not. We don't need a perfect picture here. We don't need to bust out the protractor, but we should try to draw something that is reasonable. So 89 degrees, very close to 90 degrees. This is what I'm looking for students to do. I'm not saying that's a perfect 89 degrees, but it captures the idea a little bit better, that we have a very steep angle that is very close to 90 degrees. Well, this is also 90 degrees over here, and we have a very small angle over here of 1 degree. I'm not going to bother labeling it. I'm simply going to label the opposite and the adjacent and the hypotenuse. Notice I'm not working on the xy plane here. I don't see any indication in the problem that I need to work on the xy plane, although you could. Okay, so I just look at this visually. Sine of theta. Let's look at that one. Sine of theta is opposite over hypotenuse. And I just see visually that those two sides are very close to each other. It's going to be a little bit less than 1. I'm going to put just approximately 1. If I feel like writing a little bit less than 1, I can do so, but I'm just going to say it's about 1-ish. Let's see, cotangent of theta. Cotangent of theta, that is adjacent over opposite. That's a very tiny side divided by a much larger side. So a small number divided by a much bigger number is going to be a very small number. So I'm going to put approximately 0. It's going to be very small, close to 0. Similar with cosine. Adjacent over hypotenuse, a small number over a much larger number, is going to be very small, very close to 0. Cosecant. Hypotenuse over opposite. Hypotenuse over opposite. I'm once again looking at the two sides that are very close in length. It's a little bit bigger than 1. The hypotenuse will always be a little bit bigger than opposite. If I feel like noting that it's a little bit bigger than 1, I may, but I'm just going to put approximately equal to 1 and hope that that is good enough. Let's see, we got one more choice left. Secant theta. Hypotenuse over adjacent. This is the promising looking one. Hypotenuse, a big number relative to the adjacent, a much smaller number. Big number over small number, I'm not going to speculate on what the actual number is. I'll simply say that that is a big number. This is sort of a number sense question, just getting the idea if you have a sense of relative size of these quantities we're dealing with. We want the one with the greatest value. We can be convinced that secant is going to give us the greatest value. While you're practicing, I certainly advise you to just test these out on a calculator. You're not allowed one on the test, but go ahead and just see for yourself while you're practicing. Go ahead and evaluate sine of 89 degrees, cotangent of 89 degrees, cosine 89 degrees. Evaluate all of these for 89 degrees and just really convince yourself that this analysis was correct. All right, 18. A circular toy racetrack divided into 20 identical pieces. If the outer arc of a single piece is 44 pi millimeters in length and the inner arc is 40 pi millimeters, how wide is the track? All right, well, presumably we've dealt with a number of circular track problems. You can draw the whole track if you want to. I don't really feel compelled to. I'm only interested in one of the pieces. So I'm going to draw a reasonable piece there that represents my track here. In fact, let me make that a little bit bigger. All right, and if it's a circulatory racetrack with an outer edge and an inner edge, let me finish drawing that. So here is the piece we're talking about. And let's see, we've got an outer arc of 44 pi. So let's call that S2 in contrast with the inner one, S1. And we'll say S2 equals 44 pi millimeters. S1 equals 40 pi millimeters. And how wide is the track? So what is it we're trying to find? How wide is the track? We are trying to find this length right here. That is not a radius itself. Sometimes I see students label that as a radius. That is not a radius itself, but it is the difference between this radius, which we will call R2, and this radius right here, which we will call R1. My labeling is getting a little bit messy here, but I hope you can follow that. That one is R1. So what we really want, when we want the width, how wide, we are looking for R2 minus R1. Well, by now you should know that anytime we're dealing with arcs and such, we are going to be dealing with S equals R theta in some manner. So let's go ahead and write that down. S equals R theta. And what is the theta in this case? Well, this track is a whole circle divided into 20 pieces. So that means that theta is the entire 2 pi radians, that represents the entire circle, divided by 20, divided into 20 pieces. I may reduce that to theta equals pi over 10 if I like. And while this may not be totally intuitive to the student who's brand new to this, hopefully we've done enough of this in class or in office hours to kind of make this sound familiar. I'm going to work off what I know. I see the values for S2 and S1, and I'm going to write S2 minus S1. That is going to equal the 44 pi minus 40 pi millimeters. So in other words, S2 minus S1 equals 4 pi millimeters. Now, the answer that I want, what I'm looking for, is R2 minus R1. So let's go ahead and use our S equals R theta formula. S2 I'm going to replace with R2 times theta. And S1 I will replace with R1 times theta. And that still equals 4 pi millimeters. I will factor out the theta, again, from previous activities in class. I hope this feels familiar. And let's go ahead and substitute in for theta. We said earlier that theta was pi over 10. We calculated that right up here, right? So let's go ahead and substitute that in. Just to save a little space, I'm going to erase my theta and put pi over 10. And since R2 minus R1 is what I wanted here, that's what I was striving to get, let me multiply both sides by 10 over pi. Cancels out. And what I have is R2 minus R1 equals 4 pi divided by pi gives me 4, times 10 gives me 40. 40 millimeters. That is the width of our track. So let's scroll back up here. And 40 millimeters, our answer is B. All right, on to number 19. The total perimeter of a sector is equal to twice the diameter. What is the radian measure of the central angle? Students often struggle with this one a little bit at first, but after we talk about it, they find it's not too bad. We're talking about a sector again, a pizza slice. Don't know how big of a sector, so I'm just going to draw some representative sector. It may not be to scale, may not be accurate, but at least allow me to get my head around this problem. We know that we're going to in some way be dealing with theta and R and S, and of course we have another R here. Okay, the total perimeter of this sector. Total perimeter of the sector. Again, that is adding the 2 radii plus the arc length. That is what perimeter is. So I'm going to write perimeter equals 2 radii plus the arc length. And we are told that that is equal to twice the diameter. So I'm going to say that is equal to 2 times, now I could put d for diameter, but the standard variables we seem to be working with in this chapter are s, r, and theta, s, radius, and theta. So instead of d for diameter, let's go ahead and substitute in 2r. Again, that is what a diameter is 2r. So let's see where we're at here. 2r plus s equals 4r. Well, I hope you have sort of a mathematical intuition that we should go ahead and move this 2r over, subtract it over. So if I subtract 2r from both sides, I get s equals 2r. Okay, let's remind ourselves, what are we even being asked here? What is the radian measure of the central angle? In other words, what is theta? We're trying to find theta. Well, I don't even have theta anywhere in my equations, but we should be suspicious that we haven't used our s equals r theta formula yet. That seems to always come into play here. So if I replace s with r theta, the evidence becomes clear here. We've got r theta equals 2r. I can divide out the r on both sides, and I'm left with theta equals 2. That is our answer, D. And I can't resist, I've got to just kind of redraw this and show how this really makes sense here. So if you buy all that algebra, hang around for just a minute here. Let me redraw this and show that this really makes complete sense. All right, let me try to draw something that is approximately 2 radians. That's what we deduced our answer would be. So let's say that's 1 radian, and let's say that is our other radian. I'm not trying to draw a special angle of 60 degrees. I'll remind you that 1 radian is about 57 degrees, 180 over pi degrees. All right, so let's think of why this makes sense. I don't know what the radian measure is, so I'll just go ahead and label it r. But by the definition of a radian, if this is truly 1 radian, that means that the arc length here is the same length as the radius. That's the definition of a radian. So let me go ahead and label, instead of labeling that s, which I could, I'm going to label that r, because we're dealing with 1 radian. And here's another r. Well, just take a look at this. What is the total perimeter? The total perimeter here is 1, 2, 3, 4r. We just see that staring us in the face from the picture. 4r, the total perimeter is 4r. What is twice the diameter? As we'd established earlier, here's a diameter. A diameter is 2 radii, and if I want twice the diameter, that means I'm going to take twice that 2r. And I see that this is a true statement that really affirms that our answer choice D was correct. All right, number 20. Arc 1, arc 2, and arc 3 all have the same arc lengths but different radii. Their central angles are such that theta 1 equals 1 radian, theta 2 equals 2 radian, theta 3 equals 3 radian. Pick the statement below that is true. This one always causes a little bit of confusion for students, but let's kind of get at the concept that this is really trying to explore. Let me show a little graphic here that ideally you would be picturing in your head, but I'm of course going to use some technology here to help me out. So let's look at this radius here. I've got this arc constructed such that the arc length will stay a constant length. So notice that as I vary the radius, just keep an eye on that blue arc length and notice that it is staying the same length. If you were to imagine that that S was a piece of string, that string is staying the same length. It's not getting shorter, not getting longer. But notice what happens as I'm varying to R. So notice that right now, I'm making the radius bigger. Notice that as the radius gets bigger, the theta has to get smaller in order to compensate and to keep the arc length a constant length. If I go in the reverse direction, if r is getting smaller, then the theta has to get bigger in order to compensate. So theta and r have what we would call an inverse relationship. One gets bigger, the other gets smaller. Okay, so I hope you have a visual to go along with that. I think that's important to not just rely on algebra formulas, but to really have a visual that goes along with this. Now, hopefully based on that alone, you can kind of draw some conclusions from this. But let's go ahead and tackle this with some algebra. Based on the fact that these three all have the same arc lengths for these three different arcs, that's basically saying that the arc length of arc 1 equals arc length of arc 2 equals arc length of R3. S equals R theta seems to come into the picture all the time when we're dealing with arcs. So let's go ahead and write that as R1 theta 1. Notice that neither the arc length nor neither the radius nor the theta is claimed to be equal for these different arcs. So these arcs do not all share the same theta nor the same radius, so I'm going to label them all with subscripts. All right, and let's go ahead and substitute in these values that we're given. Theta 1 is 1 radian, therefore R1 times 1 equals R2 times 2 radian equals R3 times 3 radian. And there are several things we could do from here, but I think the one that tends to make sense to students the most is just pick a sample value. We don't really know what any of these R is, but let's pick a sample one. Let's just say that R1 equals 6, for example, 6 units of whatever type, inches, meters, whatever. Let's say R1 equals 6. Well, that means that 6 times 1 equals 6, right? So what would R2 have to be in order to maintain that equation of 6? That means R2, in order to give a 6, would have to be 3, right? And if we still need that to equal 6, and I've got R3 multiplied by 3, that means R3 must be equal to 2. So let's look at what we've got here. We've got R1 of 6, R2 is 3, and R3 is 2. Let's look at the equations we are offered here. Does R3 equal R2 plus R1? Certainly does not. In fact, R3 is the smallest of the three. This is just wrong based on the premise of this problem. All these were to have the same arc length, so that is immediately wrong right there. One should not be bigger than the other. What about this right here? That appears to be true, doesn't it? R3 does appear to be less than R2, which does in turn appear to be less than R1. So that appears to be true. Once again, based on the premise that we have the same arc lengths, D here certainly seems wrong. They all have the same arc length, so you shouldn't be able to add 2 of them and get the third. And finally, E, take a look at E. That one isn't true either. Once again, R3 is the smallest of the 3 radii. And even if it weren't, even if we were to try to take the biggest of the radii, I would still say 6 squared does not equal 3 squared plus 2 squared. So that one is definitely wrong. C is our answer. All right, I hope that all made sense. Of course, if you had any trouble on any of these, I invite you to come on by during office hours and clear it up.